the ink analysis session we're having, I'm going to be analyzing ballpoint ink. The sample presentation is a little different from what you've seen. Since it's a solid sample and we are aiming for an ink line in a particular position, we have built a mount that actually positions the sample routinely in the same position each time. One can put a whole sheet of paper into the mount, but I'm just going to use little punch out circles like the one I just dropped. There it is. Pick it back up. And this is no fancy sampling. I did it with an ordinary punch out. You can get it at Staples or Office Depot. And you notice I'm wearing gloves. Fingerprints on the paper will show up and will interfere with the analysis, so you do need to wear gloves for this. All you have to do, and this is a sample mount of our own design, so you can come up with your own, but we have a hook that grabs over the paper. The hook has a hole in it so that the dart source will see the sample. When it's in like that, all we have to do is drop it into position. But of course first I have to start the machine up so it's actually acquiring data. I've already got it warmed up and ready to go. So let me give it a name. This is a Zebra brand ink, so I will call it Zebra. Demo. Can't spell. There we go. And we can use the current acquisition. So there's really nothing to change this time round. So there we go. And we let the computer think about it and set everything up. Okay, now that it's ready to start the run, we hit start run and let it start taking data. And then, as with everybody else, one needs to put a little peg in first to have a calibrant. That looks like a good swipe. Nice, good, strong spectrum. So we now have that. Since we are analyzing ink on paper, we do need to take a paper background that we will subtract off of the ink spectrum later. So you saw me put the paper sample in a little while ago. Now all I need to do is drop it in place and it will take the spectrum. So there's the spectrum of the white office paper the ink is written on. We have fairly arbitrarily decided to acquire 30 seconds worth of data and average that for each of our samples. So I'm going to let it run the full 30 seconds. That's just a wide enough time range to make sure that all the ink components that are going to come off have contributed to the spectrum. Okay, we're safely past the half-minute mark. So I can pull the blank paper out, take the hook off, discard it. Now I've got to come over here and pick up the sample I've already cut out of the ink line on paper. Whoops, I dropped it. Of course, one has to do that while one is being videotaped. That is a requirement. There we go. Now I've got hold of it. I'm going to reposition it in the tweezers a little better. Makes it easier to get it into the mount. Now it just goes into the mount so that the ink line is visible in the gap in the hook that holds the whole thing in place. That's now in, and all I have to do is drop again, and the spectrum appears on the screen. The only special condition we have is that we run with a gas temperature on the dart source of 255 Celsius. If you go up to 300, which was used for some of the drugs in the urine, you'll singe the paper. If you keep it at this low a temperature, The DART analysis has no visible change in the papers, so if you do a whole document rather than a punched piece as I just demonstrated, then there'll be no visible change to the evidence. Okay, it's now gone for its full 30 seconds, so I can pull that out. And we need to stop the acquisition. The Schrader software that you've seen demonstrated in some of the other modules is neat stuff, but I don't have it on my machine. I don't know how to use it. So I'm going to stick with the mass center software that came with the spectrometer. And let's see, what did I call this? There we go. There's the chromatogram. So the first thing, as usual, is a calibration. So you go in here and grab the PEG spectrum. And I usually do take a background blank off of it. Let the software calculate the spectrum of it. There's a nice PEG spectrum. And in the mass center software, we have to change this profile spectrum into a centroid spectrum. So those settings look just fine for centroiding. So I'll let it do the centroid. Okay, and we can close that. Now we have the centroid and the profile is above. We don't need the profile anymore, so I'll simply get rid of it. Now we have the centroid spectrum of the PEG. Going back down to the chromatogram, we can come out here to the place where the ink on paper spectrum was acquired. As I said, I want 30 seconds, half a minute, from where it first starts, which is right there. Let's see, grab hold of it, there we go. And so half a minute later, we'll be out to right about there. So that gives me the ink in paper designated. And now I want to subtract off the blank paper, so I can use Control right shift to designate that. Let's see, half a minute again goes out to right about there. And it calculates the spectrum. Okay, there we have below a nice clean looking spectrum of the ink with the paper removed. Of course it still has to be centroided, so we'll choose the centroid and apply it. And there we have our final spectrum there on the bottom. What I'm going to use is the nist spectral search software for matching this up with the library of ink spectra that I have. Although the search from list software that you've seen the others use can do this spectrum matching, it couldn't at the time we started doing our project. So we have built our library up in the nist software. You can use whichever one you want. But the nist software requires that I store the spectrum in the JEOL DX format. So there we have a place to put it, and I'll call it zebra, because although I'm treating it as an unknown, I know it's a zebra ballpoint ink that I've run. So now that that is stored, there is one further conversion that has to be made before the nist software will accept it. And fortunately there is a little module that will change the JSP file that was just written into the nist format. So let me go browse over to where the data is stored. If I can find it, there we go, mass center, JODX, workshop 814, and there's the file I want. So I've told it, and it should have written the converted file into that same folder. So now I can bring up the nist software and read the file in. If I go to the right place again, so we go over to the workshop and today's date, and the file is not there. I'm not sure what the problem is. Let's look at all the files and see. The module did not write it into that folder. Okay, the new little module I've been given didn't do what it's supposed to, so we will try again. Okay, I have opened it, and I thought it was supposed to simply directly write it. We may have to stop, and Chip may have to tell me how this program works, because I don't know what the problem is. If you're out there, Chip, I need you. I'm not getting any response. All right, I'm going to assume Chip is not here, and therefore I cannot use the module he gave me this morning. I'm going to use an old-fashioned technique that I know works, but will take a couple of extra minutes. Yeah, the module, I brought the file in, and nothing happened. It didn't write anything, or else it wrote it in a place I can't find.
It's supposed to write it in the same directory. Let's see.
Yeah, I opened it. I went to File, Open. Well, now it's lost a place to pull it from. Whoops, no, that's not the right place. I will have to go to Mass Center, and then to the Joel DX folder, and then Workshop within that, and then 814 within that, and I grabbed the thing and said OK, and I thought it would automatically write it.
To tell you that it's working. Let's see if we can find it. Find out where it went, because this is a new program. Let's see. I think I'm going to have to put some message in here.
This, I'm picking it up at the point where I've just saved the JEOL-DX file. Everything after that won't work because the software presently on the machine does not function. I'm going to use a different technique for doing everything after that point. So you can edit from where I saved the JEOL.
You gotta restart it again.
Just in case the audio didn't record to the editor, I'm picking it up from the point just after I have saved the spectrum as a JEOL-DX file. Everything after that point will have to be discarded because the software needed doesn't work. I'm going to use an alternate way of doing things after the point where the JEOL-DX file was saved. So, coming back where we are now, the file has been saved, but the format isn't quite what the nist software wants, so we have to do a change in the header. That's the sort of header that the nist software wants to see. The file just saved is this one, which has a longer header. My easy way of fixing it is to go to an old nist file and grab its header and simply copy it in to the file I've just created, like that. The only two things that are really important in the header is the name, which happens to be just about the same as the old one I'm copying from, because the old one was a previous test of the same ink, and this quantity called endpoints. So I'll take the number down here in the new file, 256, and put it into the old header, 256, not 156. Okay. We can then get rid of the header that was in the new file, and we have just the old style header on this new file. So we save that, and I'm going to save it with the JDX extension because that's what the NIST software likes. You can tell it to read the other kind, but JDX is what it likes. So we'll save that. Now we can get rid of those files and bring up the NIST software. If you go to the Librarian tab where it already is, you choose that icon to load in a JDX file, which hopefully is stored in the workshop folder and today's date. And I choose JDX because that's what I'm bringing in. There it is. Grab it. Tell it we want to import all the files in that folder. We can overwrite the old thing that was there. And so now we have it in. Now when you're using this software for the library thing, you need to go up to the options and set the library search options. I've already got them set. Identity or similarity search doesn't make a lot of difference. Forward and reverse search is possible. I'm going to use a forward. Match number rings has no meaning when you're doing an ink spectrum since you have more than one compound present. Libraries is important. I need to have my ballpoints library chosen. I'm not going to use any limits or any constraints on the analysis. So everything is now set. And if I right click, I can then tell it to do a library search. And there it has searched the unknown, which it shows here at the top. And here's the list of library entries it found that it matched. And the one up here at the top with the highest match quality is, thankfully, another zebra rubber ballpoint pen spectrum. So it did match with the correct spectrum. Over here you see the spectrum I've just brought in, and here at the bottom is the highlighted spectrum from the match list, which is the one at the top at this point, and you do see the two spectra match reasonably well. So that's the way you match spectra after taking their spectra from the DART system. That's the end of this module.